Hello, scientists. So this presentation is about balancing chemical equations, and I'm going to start with some visual modeling first, and then slowly go down to where it's more numbers and less of the pictures. Honestly, when you are doing your work, if going back and drawing the pictures helps, or doing models such as this helps, do it. Use those manipulatives. They're wonderful. They're fantastic. Um, or just save it for when you are checking your work. Okay. So without any further ado, here we go. So we understand that with the law of conservation of mass and matter, that mass and matter cannot be created or destroyed. Instead, it's just transferred. It transforms. It goes into different things after the chemical reaction. So what we have here is we have the reactant on the left side and the product on the right side, okay? And what we want to see is that with zinc, there is only one zinc atom. For hydrogen has one and chlorine has one, all on the reactant side. But on the product side, we have one zinc. The 2 here shows us that we have 2 chlorines, just like the 2 here shows that we have 2 hydrogens. When I am setting up to balance a chemical equation, I like to go under and just from left to right, jot down my elements that I have on both sides of the equation. And then to get started, I like to put down how many elements do I have on each side. So for zinc, I have 1 on the reactant side, and of course 1 on the product side. I do the same thing for hydrogen and chlorine. At any point, feel free to go back and rewatch this video. And now, my next step is to see what is balanced and what is not balanced. What I notice is that my hydrogen is not balanced and chlorine is also not balanced. Well, I can't just take away atoms to make this thing work, but what I can do is add atoms. So starting with hydrogen, I'm going to add 1 atom. And then what I have to do in the equation above is add a coefficient to say that I added another hydrogen to note that I have 2 hydrogens. Here's the thing though, chlorine is right here. So this 2 also applies to chlorine. So we have to add another chlorine. Now I see that my zinc is balanced, my hydrogens are balanced, and my chlorines are balanced on both sides of the chemical equation. Now to check my work, I may go back and work through again to say this is an understood 1 if it is zinc, so I have 1 zinc. I now have 2 hydrogen and 2 chlorines. On the other side, I have 1 zinc, 2 chlorines, and 2 hydrogens. Let's do the next one. Now here's another one that's really small, and I notice that we have 1 sodium on the reactant side and 2 sodiums on the product side. For oxygen, I have 2 oxygens on the reactant side and 1 on the product side. So now I see what is balanced and what is not balanced. I want to start with sodium. So for sodium, I'm going to add 1 sodium to the reactant side, so I need to put a coefficient of 2 in front of sodium. Now sodium is balanced. However, my oxygen remains unbalanced. So to do that, I need to add a coefficient of 2 to the product side to show 2 oxygen. But here's the thing, I also have sodium to consider. And so 2 multiplied by 2 is 4. I now have 4 sodiums on the product side. So once again, my sodium is unbalanced. To fix this, I need to add 2 more sodiums to the reactant side and change that coefficient to 4. Now we are balanced. Let's look at another one. This is a really large chemical equation, but do not be overwhelmed. Just follow these simple steps. First, from left to right, list your chemicals, elements that are on both sides of the equation, and then fill in to see how many you have. Like for sodium, there's an understood coefficient of 1, so all I have to worry about is the 2. So I have 2 sodiums on this side and 1 sodium on the other side. For sulfur, I have an understood coefficient of 1, but no subset, so there's only 1 sulfur. And that is also true on the other side of the equation, on the product side. But let's take a look at oxygen. The coefficient is understood 1, but I have a 4. So this means I have 4 oxygen. And the same thing applies to the product side. Now, let's look at calcium. Calcium has an understood coefficient of 1 and no subsets. So that's only 1 calcium. And I notice the same to be true on the product side. Last but not least, chlorine. You guessed right. 2 chlorine on the product side and 2 for the reactant and 1 for the product. Now I have a clearer image of what is balanced and what is not balanced. From the top, I notice that sodium is the unbalanced. So I want to go ahead and fix that. How do I fix that? Yes, I have to add another sodium to the product side, meaning that I now need to put in a coefficient of 2 in front of this part of the equation, in front of this molecule. However, because I put a 2 here, I now have to add another chlorine. And as you can see, now both sides of the equation is balanced. So I want you to know that even though it looks like there's a lot of atoms and molecules involved, that one little change might be all you need. Okay, for this one, I am removing the manipulatives to show you how you can use only the numbers to show your work. Okay, so for this one, we're using aluminum and oxygen, and my first step is to lay out from left to right the elements that I'm using. I just copy that on both sides. Okay, so here we go. So for aluminum on the reactant side, I notice I have 2. And the aluminum on the product side, I have 1. For oxygen on the reactant side, we have 3 oxygen. And then, of course, 2 on the product side. And now I can tell from my numbers that 2 is greater than 1 and 3 is greater than 2. But all of my elements are not balanced here. So we have to fix that. So I want to challenge you to pause this video and try this one by yourself first, and then when ready, resume the video to check your work. All right, scientists, let's check your work. So first, let's deal with aluminum. So to help balance aluminum on both sides, I'm going to put a coefficient of 2 in front of aluminum. So it's like I'm grabbing another piece of aluminum from the cabinet and adding it to balance my chemical equation. But now I have to deal with oxygen. Oxygen is not as simple as we have done previously. I have a 3 and I have a 2. So with a situation like this, I think of what is 2 multiplied by 3? Oh, that is 6. Since oxygen, there's 3 oxygens on the reactant side, I'm going to put 2 as the coefficient on this side. On the product side, 2 is here, so I will use 3 as my coefficient. So let's plug those numbers in. Okay, now as I go back and double check my work, I notice that 2 multiplied by 2 is 4. So on the reactant side, I now have 4 aluminums. Now my aluminums are unbalanced once again, so I have to fix that by adding 2 more aluminums to the product side of the equation. Now my work is done. And always go back and check your work before you go on to the next one. You take the coefficient, so 2 times 2 is 4, 2 times 3 is 6. Check your work down here and then see if you balance on the other side using the same method. Always check your work. Otherwise, if you don't double check your work and you actually are doing the chemicals with this, you might end up with a reaction that you are not prepared for. So scientists, I hope you found this video helpful and that it's going to help you with your homework and with all your classwork and what you're learning to do with chemical equations. If you would like further assistance, reach out and I can see you during tutoring. Bye guys.